Hi, welcome to Special Relativity. We mentioned then that Einstein started his 1905 special relativity paper presenting an apparent paradox involving electricity and magnetism. Let's talk about electric fields and relativity. A parallel plate capacitor is a device designed to store electrical charges and therefore energy. We have two parallel metal plates of surface area A at a distance d. From courses in introductory electricity and magnetism, we know that from Gauss's law we can calculate the electric field of a charged capacitor. Assume we have a charge density positive and negative sigma at each of the plates. The electric field between the plates is sigma over epsilon naught, where epsilon naught is the electric permittivity of vacuum. And the electric field outside the capacitor is zero. This result is valid for two plates that are very close in comparison to the size of the plates. The electric field is constant inside the capacitor. It does not depend on the position if we avoid the far edges. We represent this electric field with parallel field lines from the positive plate to the negative plate. Usually, the separation of the field lines represents the intensity of the electric field. The closer, the more intense the field. And this field only depends on the charge density on the plates. Let's consider now a reference frame that moves along the x-axis, parallel to the plates. Because of length contraction, the plates are going to be contracted. This means that the charge density is going to increase by a factor of gamma. Electric charge does not depend on the frame, so the same charge is going to be distributed in a plate that makes A on one side, but A over gamma on the other side. So sigma prime is now gamma sigma. The electric field lines are now closer together. Now we can apply Gauss's law again and see that the enclosed charge is larger by this gamma factor. So the electric field perpendicular to the motion of the moving frame E perpendicular prime is gamma E perpendicular. Now let's consider a capacitor that is vertical instead of horizontal, and we observe it from the moving frame. In this case, the distance between the plates is shorter, but the surface area is the same. The electric field does not depend on the distance, and we find that the electric field parallel to the motion of the frame does not change. E parallel prime is equal to E parallel. This result found for this particular case is in fact a general result of how the electric fields transform from a rest to a moving reference frame. May the science be with you.